Now today I'm going to introduce you double integration. The meaning of double integration is uh, integration in two dimension. Now what is the meaning of integration in two dimension? If you look at the definite integral, what you all might have seen, x is equal to a to x is equal to b, fx, if I am integrating, what exactly I get by doing this integration? If you look at that, suppose x is varying from x is equal to a to x is equal to b. In this variation, x is varying from a to b along the x-axis, isn't it? So from a to b, x is varying, and correspondingly there will be variation in fx. So fx is varying from one point to the another point. In this graph, I have drawn the curve of fx. But suppose x is equal to a to b, it's just a conductor wire, straight wire, and fx is representing the density of electric charge. So how much electric charge will be present in dx length? That will be fx into dx, because fx will be the density, then fx will be the electric charge present per unit length, and how much electric charge present will be in dx, that will be fx into dx. So how will you calculate how much total charge is present from a to b? You integrate this function fx along with this dx from point a to b. So don't keep this notion in your mind that by doing the integration we always finding the area. We do find the area by doing this integration when this fx is representing this height. Then fx into dx represent the area of a small strip, and that kind of a strip's area you are adding from one point to the another point. That's what we do in the single integration. Now suppose, now fxy is this function of two variable, and this representing the electric charge density of this plate. It's an elliptical plate I have drawn, okay, just for understanding. Fxy represent the density of electric charge of this plate. I want to find out how much total electric charge present on this plate. How this double integration can help me, and along with that you can understand what double integration exactly represent. Suppose this particular point is x is equal to a, this point is x is equal to b. This curve is y is equal to f1x. This curve is y is equal to f2x. Now, if I want to find out how much total electric charge present on this plate, this fxy represent density. So I'm taking a small patch, a rectangular patch whose width is dx, height is dy. So the area of this patch is dx dy. So fxy is the electric charge density. This is the electric charge per unit area. So how much electric charge present on dx dy area? That is fxy dx dy. This is the electric charge present on this rectangular area. Now can I integrate this on the region of this elliptical part to find out how much total electricity charge present on this plate? That's what the double integration do. Now how to go about it? Now when I'm trying to do the double integration, we do take a vertical strip or a horizontal strip. I'm making you first showing you how to go about the with the help of the vertical strip, then we can go with the horizontal strip. So I've taken a vertical strip. So I'll be doing my first integration on this vertical strip. When I'm saying first integration in a double integration, this is the first integration, and this will be the second integration. This will be first performed, this will be second performed. So this integration is always the integration on the strip. And when I try to do this integration, we write this, that from which curve my strip is starting and to which curve it is going. So it is starting from y is equal to f1x and going to y is equal to f2x. I have written y is equal to because my strip is parallel to y axis, and I'm to write the limit I'm writing y is equal to f1x, y is equal to f2x. By doing this, what I'm doing, I'm bounding my strip. Look at the pen. It's like I'm bounding this pen between these two curves, upper curve as well lower curve. So my strip cannot go beyond this. That is why whenever we write this strips limit, we always use those curves to write down the limit. Now y is equal to f1x to y is equal to f2x. Now my strip is bounded between these two curves. Then we can freely move it from x is equal to a to x is equal to b, bounded between these two curves horizontally. So a strip can be moved from x is equal to a to x is equal to b. X is equal to a to x is equal to b. This vertical strip which is bounded between these two curves can be moved horizontally to cover the entire region. That's what the entire idea. So first I'll be doing the integration on this strip. So while doing the integration on this strip, there is variation only along y-axis. There is no horizontal variation. There is no horizontal variation. There is variation only along y-axis. So if there is no horizontal variation, that means when I'm doing the integration with y, I will treat x as constant. So I will be doing first integration with y, treat x as constant. Then second integration with x and put the limit. For example, in the above case, if you first integrate with y, suppose after doing the integration that becomes a function of xy, and you substitute y is equal to f1x to y is equal to f2x dx. Then when you substitute y is equal to in your answer, it will be totally a function of x. And then you integrate it, it will give you some constant. That will be your final answer. So that's the entire idea. So what you did exactly in this, first you founded how much electric charge is present on this patch, rectangular patch. Then you moved it along y-axis on this strip, and you founded how much total electric charge present on this vertical strip. Then you move it horizontally, that strip, and you covered the entire area of this elliptical region. That's what the entire idea about double integration. Thank you.